Carpool Chemistry. Today, we're going to learn how to write formulas and names of ionic compounds. In order to determine if a compound is ionic, you want to ask yourself, is there a metal? Because most metals want to give away electrons, and when they give away electrons, they attain a positive charge, and then they bond with another negatively charged ion. If there is a metal in your compound, then yes, it's an ionic compound. If not, most likely it's a molecular compound, which we will discuss in a later edition of Carpool Chemistry. Let's take a look at some ionic compounds. We have sodium chloride, magnesium chloride, lithium oxide, and aluminum oxide. Because these all have metals, sodium, magnesium, lithium, and aluminum, they are ionic compounds. But what ratios do they combine with the negative ions? Well, let's take a look at sodium. From our oxidation number table, we see that sodium has a +1 charge. So I like to put the +1 right there so we could see it side to side with the negative ion. Chloride, which is -1. Now our compounds want to attain a stable neutral overall charge. +1, -1 cancels out. This is indeed a stable neutral compound. So we can clean that up and write that as NaCl. And to name it, we simply say the name of the first positive ion, sodium, and then the name of the second ion, well, it's chlorine, and when we turn chlorine into an ion, we call it chloride. So it's sodium chloride is the name. Let's take a look at magnesium chloride. Magnesium, as we see from our oxidation number table, has a +2 charge. So let's put a +2 right there. And chloride has that -1 charge that we talked about earlier. Now, is this a stable neutral compound over here? As it's written, it is not, because there's too many positive charges. +2, only a -1 from the chloride. Well, how many total of these chlorides do we need to match up with the +2 of magnesium? As it turns out, we would need 2 of them. So we write 2 as a subscript here, because 2 of these -1 charges comes out to -2, canceling out the +2 from magnesium, giving us a stable neutral charged compound. So we write this as magnesium MgCl2. And to name this, we simply say magnesium chloride. Now notice how even though there's 2 chlorines, you don't have to say dichloride. You just say magnesium chloride. There's only one way that this will work. We'll use the dis and tris and tetras and pentas a little bit later on when we talk about molecular compounds, because that's when we'll need them. Let's take a look at another example. Lithium and oxygen. Well, lithium, as we see from our chart, is a +1 charge. Oxygen, in its ion form, is oxide with a -2 charge. And so, how many of these +1 lithiums do we need in order to cancel out or match up with this -2 from oxygen? It looks like we'll need 2 of them, because 2 +1 charges comes out to be +2, and +2 and -2 cancel out to give a stable neutral compound. And so we clean this up, Li2O. And to name this, you simply say the name of the first ion, lithium, and then instead of oxygen, it's oxide with the IDE ending. Once again, even though there's 2 lithiums, we do not have to say dilithium here, because it's an ionic compound. Let's take a look at aluminum and oxygen. Aluminum, as we see, has a +3 charge, so let's put that there. Oxygen has a -2 charge, as we saw earlier. Now, how can we get, in what ratios can we put aluminum and oxygen in order to have an overall stable neutral compound? It's not quite as easy as magnesium chloride and lithium oxide. However, if you take a look at positive 3 and minus 2, what number is common to both 3 and 2? That is, what is the least common multiple of 3 and 2? The number that's common to both 3 and 2 is the number 6. And that is, we could relate 3 to 6. We could also relate 2 to 6. They're multiples of each other. And how do we get a positive 6 charge? We put a 2 over here with the aluminum because 2 positive 3 charges is positive 6. How do we get a negative 6 charge to match up with that positive 6? We put a 3 over here to get minus 6 matches up with positive 6. Now we have an overall stable neutral compound. We can clean that up, Al2O3. And to name it, we would simply say Al is aluminum, or as the British would say, aluminium, and the O3 would be oxide. Once again, we do not have to put dialuminum trioxide because there's only one way that this aluminum and this oxygen are going to combine in this case in order to have a stable neutral compound. Let's take a look at polyatomic ions. It's a similar thing, except instead of having monatomic negative ions, you have polyatomic negative ions. Sodium is a +1 charge. NO3, that's the nitrate polyatomic ion, which has a -1 charge. And here, because sodium and nitrate +1, -1, they cancel out, leaving us with a stable neutral compound. We simply call this NaNO3. And the name for it is Na is sodium. NO3 is, like we see on our chart, nitrate. So you simply call it sodium nitrate. Let's take a look at calcium nitrate. Calcium, as we see, is a +2 charge. So you put a +2 here. Nitrate, -1 charge. How many of these -1 nitrates do we need to match up with the +2 calcium? It looks like we'll need 2 of them, because 2 times -1 is -2, matches up with +2 to yield a stable neutral compound. So to clean this up over here, CaNO3 taken twice. And to name this, we simply give the first word is calcium, and the second part is nitrate. And once again, even though there's 2 nitrate ions, we do not need to say di inside the naming over here because it's an ionic compound. There's only one way that this will work. Let's take a look at calcium carbonate. Ca is a +2, carbonate is a -2. To confirm, Ca +2, carbonate's a -2. +2 -2 matches up, 1-to-1 ratio, CaCO3. And you would simply call that calcium carbonate. And let's do a couple more. Li and CO3. Li is a +1, carbonate's a -2. Is this an overall stable neutral compound as it's written here? Nope. How many of these +1 lithiums do we need in order to match up with this -2 from carbonate? We need 2 of them. Now we have a stable neutral compound, Li2CO3. And we would simply name this. Li is lithium, and CO3 is carbonate. And finally, here's one with 2 polyatomic ions. NH4 is the ammonium ion that has a +1 charge. SO4 is the sulfate ion, which has a -2 charge. And it looks like you need 2 of these ammoniums in order to match up with the -2 from the sulfate. So to clean that up, NH4 taken twice, SO4. And the name for that would be simply ammonium. That's the name of the first ion. And the name of the second ion is SO4 sulfate. And one last thing about this formula here. The question is how many atoms of each element are in this formula NH4 taken twice, SO4. Nitrogen, you would have, well, each package has one nitrogen, and you have two packages, so we have two atoms. Hydrogen, well, each package has 4 hydrogens, but you have 2 of these packages here, and so that's 8 atoms. Sulfur, 1 atom, and oxygen, 4 atoms. And that's how you write formulas and names of ionic compounds.
From Levi Stadium in Santa Clara, California, this is Carpool Chemistry. Thanks for watching!